Today I will be talking about Grand Canyon National Park. First, I will be covering a challenge the park faces. I will look at the impact of building the Glen Canyon Dam and the effects caused by the dam on the Colorado River in Grand Canyon National Park, and also the creation of Lake Powell. Then I will look at the geological makeup of Grand Canyon National Park. Grand Canyon National Park is located in northwestern Arizona. The park is outlined in green. Notice how in the upper right corner is Lake Powell. Glen Canyon Dam is located on the south side of Lake Powell. You can also see how the Colorado River flows through the park. This picture has the same boundaries as the last picture, but it shows more of the geological features of the park. Lake Powell is still located in the upper right-hand corner near Page, Arizona. This picture also allows you to see the Colorado River in greater detail as it flows through the park. Congress approved Glen Canyon Dam to be built in 1956. By 1963, the dam was completed. 17 years later, in 1980, Lake Powell finally finished filling up. Glen Canyon Dam stands 710 feet tall and is only 16 feet shorter than Hoover Dam. A key point to notice in this picture is how the water is a turquoise green above the dam and very blue below the dam. This is an important factor, and we will touch on this later. Lake Powell is the second largest lake in the United States used for water supply. It is 186 miles long, and its deepest point reaches 558 feet deep. Glen Canyon Dam is located near the bottom left corner where it says Lake Powell, near Page, Arizona. So how does Glen Canyon Dam and the creation of Lake Powell impact the Colorado River in Grand Canyon National Park? There are a few positive and negative impacts. We will look at the positive effects, which are electricity, economic and recreation, and water storage. Then we will look at the negative effects, which include sediment in the river, water changes, and the impact on fish species. Glen Canyon Dam produces electricity using hydroelectricity. A benefit to hydroelectricity is that the power it creates is clean. It just needs the moving water from the dam to create the energy. Hydroelectric power also has low failure rates and low operating costs. But one downside to hydroelectric power is that the energy it makes cannot be stored for future use. Glen Canyon Dam produces 4.5 billion kilowatt hours per year, which is equivalent to burning 2.5 million tons of coal or 11 million barrels of oil. There are 8 generators that create power inside Glen Canyon Dam, and they are pictured here. Glen Canyon Dam and Lake Powell have a great impact on the local and regional economies. Over 2.5 million people visit the Lake Powell-Glen Canyon Dam area each year, generating over $400 million to the area economy. There are many activities to do in the Lake Powell area, like rafting, sailboating, fishing, renting houseboats or regular boats, kayaking, water skiing, and much, much more. Lake Powell is used as a water reserve that provides water to 7 states in the southwestern part of the United States. Lake Powell plays a crucial role for these states, especially during drought seasons. It can hold 26,215,000 acre-feet of water at full capacity, which is about 8.5 trillion gallons. About 40 million people rely on this water for crops, drinking water, and flood control for those below the dam. 85% of the water from Lake Powell is used for agricultural reasons, and about 25% of U.S. crops are watered by the water from the Colorado River and Lake Powell. We are now switching over to the negative effects caused by Glen Canyon Dam. Before Glen Canyon Dam was built, the Colorado River would flood every spring and occasionally times after. Approximately 60 million tons of sand would be washed in with the floods each year, creating sandbars along the banks of the river. Now that the dam is built, it cuts off 94% of the sand sediment from flowing down the river because it settles into Lake Powell. Scientists realized the lack of sediment was causing the sandbars to be washed away. They have attempted artificial floods by opening the dam wide open to try to bring back the sediment to the riverbanks. These floods do bring back sediment during the flood, but soon after they stop it, the sandbars are quickly washed away once again because of the controlled flow of the dam. Glen Canyon Dam is drastically changing the riverbanks in Grand Canyon National Park. Before the dam was built, the Colorado River would run as a warm, reddish, muddy-looking water through the Grand Canyon. The temperature of the river would vary throughout the year from freezing to about 80 degrees Fahrenheit. Now, since the dam was built, the river below the dam runs much colder at an average of 46 degrees year-round. The water has become clear and appears turquoise above the dam and blue below the dam, which indicates major environmental changes. In the pictures, you can also notice the sandbars on the banks I just talked about. The picture on the left was taken in 1906, well before the Glen Canyon Dam. The picture on the right is a recent picture that shows how those once sandy shores have changed and washed away. The colder water in the river has taken an impact on the fish that live in it. 5 native fish of the Colorado River are on the endangered species list. A few of the species are only found in the Colorado River basin. One species in particular that is endangered is the humpback chub, which is pictured right. Colorado River in the Grand Canyon is only one of 6 locations the humpback chub survives. Native fish are struggling with colder temps of the river, while non-native fish are thriving. Specifically, trout thrive in the cold Colorado River. Trout are moving in and they are natural predators to the native fish. From 2001 to 2008, there was an increase in the temperature of the river, and there was a noticeable difference in the native fish population. They started to see an increase in the native fish and a decrease in the non-native fish. This shows how the changing water temperatures impacts these fish species.